Hello, and welcome to my video on the January 2019 Algebra 2 Regents, question number 21. In this problem here, we're asked to determine which expression or expressions are equivalent to x squared minus 4x over 2x, where x does not equal to 0. So to see which is equivalent to what we start off with, let's recall what we can do to simplify a rational expression. And if you recall, when trying to reduce a rational expression, right, we're not going to do any tabular division or box here, box method. To simplify this, what we can do is we can try to factor the numerator and denominator. So in the numerator, if you notice, we can factor out a GCF of x. And when we do that, we have x minus 4 left over. And then this is still all over 2x. And 2x, there's nothing to perhaps factor there. But now that we've factored this, remember that any common factors in the numerator and denominator can be reduced. And a common factor would be x. X is a common factor in our numerator and denominator, so we can just reduce those, and then we are left with just x minus 4 all over 2, and that actually is option 2. So that is an equivalent expression and is part of our answer. Now, all the choices, unfortunately, have choice 2 as an equivalent expression, so we have more work to go here. To perhaps see if choice 1 is equivalent to our expression, we could start with x over 2 minus 2. And what we can try to do here is we can actually try and perform the operation of subtraction to see if this is equivalent to this x minus 4 over 2. And to subtract these, because we have x over 2 as a fraction, we can make 2 into a fraction by putting it over 1. And whenever we want to subtract two fractions, we need a common denominator. The common denominator of these two fractions, I hope you would agree, is 2. So that would mean that we have to multiply the second fraction, numerator and denominator, by 2. So we would have the denominator is 2, and the numerator would be 4. And then when we subtract these fractions, same denominator, and we just subtract the numerator, and we see that that first expression is equivalent to our original expression. So choice 1 is a possible answer. But now, how about choice 3? Well, if you look at choice 3 here, again, we have a similar situation of two fractions that are being subtracted, and they already have the same denominator, which means that since they already have the same denominator, we can actually perform the subtraction. So if we subtract the numerators, we have x minus 1 in the first numerator, and we need to subtract the second fraction's numerator of 3. And if we actually perform that subtraction, x minus 1 minus 3 just becomes x minus 4. And once again, that is equivalent to our expression, and thus choice 4 is our answer to this problem. So I hope that this was helpful to helping you understand this particular problem. I will say that as a multiple choice question, what you could also perhaps do to answer this problem if you weren't able to figure this out is you could perhaps just choose, say, a number for x, just pick a particular number, say x equals to 1. I wouldn't pick x equals to 0 because we can't divide by 0, but if we say choose x equals to 1, you could plug that into the original expression, get a value for that, and then you should be able to plug it into each of these choices, x equals to 1, plug it in each of these choices, and since each of these were equivalent, when we plug x equals 1 into these choices, we should get the same value that we got when we plug x equals 1 into this expression here, and thus verify that each of these are equal. So that would be an alternative way to have answered this problem. But either way, I hope that this video helped you out with this particular question. As always, good luck with your studies, and thank you for watching. Take care.